let's consider some different types of slopes. So we're given this line here, and we see that this line slopes upward this way. So we say that this is a positive slope because it slopes upward. In mathematical language, we say that the slope is equal to the rise over the run. But technically, we say that it's equal to the change in y divided by the change in x, right? Because we see that this one rises up from this point here, 0, 3. It rises up 1, 2, 3, and if we consider this point here, it runs over to here. I'm going to try to draw that line as straight as I can. And that run is 1, 2, 3, 4, 5, 6, right? So it has a run of 6 and a rise of 3. So we see that the rise is 3, the run is 6, and so the slope is equal to 1/2. And that's positive 1/2, right? Okay, so that's the first type. Here's the second type. This line is sloping downward, so we say that this is a negative slope because the slope in the language that we use, we usually say rise over the run, right? But this thing doesn't rise because if we look to get from here to here, we have to drop down. So really, we might use the language the drop over the run. And that's why it's so convenient to just say this is just equal to the change in y. And that change in y might be positive and it might be negative, divided by the change in x. And so this is just more convenient notation. It's also less writing. It's easier to write down. So the change in y is 1, 2, 3, but because it's going this way, you're changing in the negative y direction, right? So -1, -2, -3. So the change in y is -3. And then the run is in the positive x direction, 1, 2, 3, 4, 5, 6. So this is 6, right? So then the slope is equal to -1/2. So we see that these two slopes are equal in magnitude, but opposite in sign, all right? Let's consider the next type. The next type is a line that has a slope of 0, right? It's not tilted down, it's not tilted up, it's just like this. So it's not sloping at all, right? And if we say the slope m, now we're going to use our technical language because we don't want to worry about this rise or drop or whatever. Let's just say delta y over delta x every time. It never changes its y value. It always has a constant y value of 1, 2, 3. So this graph is the line y is equal to 3, like so. And so the change in y is always 0, right? And then x, you could let the change in x be anything. It doesn't matter if you go from x equals 0 to x equals 10. Change in x is 10, put it down here, still 0. You could go from x equals 0 to x equals 5, right? If you put a 5 here, still 0. So the slope is always equal to 0, right? No matter what your change in x is. And in fact, for every x, we see that for the solution for this line is that for any x value, the y value is always equal to 3, right? All these x values have a corresponding y value of 3 for this function. Okay. The next type of slope is one where it's essentially undefined, right? Because look how this line just is straight up and down, it's vertical. And so if we say the slope m is equal to delta y over delta x, right? If we change by some small amount delta x, right, then we're completely off the graph, right? So the slope of this thing is just straight up, it's infinite. Because you can imagine that a slope of something like this having a slope of, say, 2, and then it has a slope of 3, and 4, and 5, and 6, and then it's getting to the point where a little change in x is going to give you a very big change in y, right? And when it goes vertical, a little change in x is going to give you essentially an infinite change in y, right? But a little change in x and you're no longer on the graph anymore. So this slope is said to be undefined. Undefined. And make sure that made it in. It did. Okay, so this is just different types of slopes. I'm going to step out of the way, give you a clear screenshot.